السلام علیکم. آج ہم سافٹ ویئر کوالٹی ایشورنس کے 10th لیکچر میں ہیں. پچھلے 3 لیکچرز میں ہم نے سافٹ ویئر ریکوائرمنٹس اور سافٹ ویئر ریکوائرمنٹس انجینئرنگ کے حوالے سے ڈسکشن کی تھی، اور ان 3 لیکچرز میں ہم نے دیکھا تھا کہ کس طرح سافٹ ویئر کوالٹی ایشورنس کی کیا امپورٹنس ہے ریکوائرمنٹس کے حوالے سے، اور کس طرح ہم ریکوائرمنٹس کو ایک ہائی کوالٹی ریکوائرمنٹ سیٹ میں کنورٹ کر سکتے ہیں. یعنی ہمارے پاس را ریکوائرمنٹس ہیں اور ان کے اوپر ہم کیا پروسیسز، کیا ایکٹیویٹیز پرفارم کر سکتے ہیں. کن چیزوں کا ہمیں خیال رکھنا پڑے گا کہ جب ہم ریکوائرمنٹس ایکٹیویٹی کو کمپلیٹ کر رہے ہوں تو ہمارے پاس ایک ہائی کوالٹی ریکوائرمنٹ سیٹ ہو، ہمارے پاس ایک ایسی ریکوائرمنٹ ڈاکیومنٹ ہو جو ان کوالٹی ایٹریبیوٹس کو میٹ کر رہی ہو جو کہ ہم نے ڈسکس کیے تھے. اور اس ریکوائرمنٹس ڈاکیومنٹ کو لے کر ہم ایک اچھی ڈیولپمنٹ اور ڈیزائننگ اور ڈیولپمنٹ ایکٹیویٹی کو سٹارٹ کر سکیں. آج سے ہم سافٹ ویئر ڈیزائن کے اوپر بات کرتے ہیں، اور ہم دیکھتے ہیں کہ سافٹ ویئر ڈیزائن جو کہ ایک بہت ہی اہم ایکٹیویٹی ہے سافٹ ویئر انجینئرنگ لائف سائیکل میں، اس کا کیا ریلیشن شپ ہے سافٹ ویئر کوالٹی کے ساتھ، اور کس طرح ہم ڈیزائن کے مختلف ایکٹیویٹیز کو کوالٹی ایشورنس کے ساتھ ریلیٹ کر سکتے ہیں، کس طرح ہم ڈیزائن کی مختلف پروڈکٹس کو سافٹ ویئر پروڈکٹس کی کوالٹی کو بہتر کر سکتے ہیں. یہی ہمارا مقصد ہے. تو آج ہم پہلے سافٹ ویئر ڈیزائن کا ایک انٹروڈکشن کریں گے. اس کے بعد ہم سافٹ ویئر ڈیزائن ماڈل اور سافٹ ویئر ڈیزائن پروسیس، یہ 2 کانسیپٹس ہیں، ان کو ہم ڈسکس کریں گے. اور آخر کے اوپر ہم سافٹ ویئر ڈیزائن ڈیفیکٹس کو ڈسکس کریں گے. جیسا کہ آپ کو پتہ ہے کہ ڈیفیکٹس جو ہیں وہ کسی بھی پروڈکٹ کی کوالٹی کو خراب کرنے میں بڑا اہم کردار ادا کرتے ہیں. If defects are present in any work product, they are definitely going to have a result into a poor quality of that work product. So what is a design? A design is some sort of a plan, an arrangement, a layout, or a map. What it is not is an accident or a chance or guess or fluke. So when we say design, the first thing that should come to our mind that we have to plan something. It is not going to be an accidental activities of things happening. Design is an activity for creating a solution that satisfies the customer's requirements. جب تک ہم requirements کی ڈسکشن کر رہے تھے تو ہم نے کہا تھا کہ ہم ابھی پرابلم ڈومین میں ہیں، ہم سولوشن کو اسپیسیفائی نہیں کریں گے. The requirement sets would then describe what the system does. But when we come into the design phase or design activity, we start talking about implementation, we start talking about how a solution can be reached. And so design is the backbone of all activities, all products and services. And for softwares, it is the first step where we start talking about the implementation aspects of the software product. Many people consider design as an artistic or heuristic activity because there are no engineering or mathematical principles that will guide you in designing a software system. However, that's true for all the different activities in software engineering. And research in this profession has resulted in a lot of good characteristics for software design. We have been able to come up with design principles and very good design concepts which result in high quality software. So one is not alone and feeling helpless in designing software systems. So let's continue our discussion with on software design. Software design is an artifact that represents a solution, showing its main features and behavior, and is the basis for implementing a program or collection of programs. So it is an intermediate step or intermediate work product or intermediate process between the requirements engineering processes or requirements engineering activities and implementation of the design. So design is a very important and a basis on which the programs are written or code is developed for the executable system that we are developing. So let's continue our discussion with respect to design. It can also be considered as a meaningful representation of something that has to be built. We don't have an executable system when we are designing, but it represents the system that will be implemented. It can be traced to customers' requirements because the design is based on the customer's requirements, and at the same time it has to be assessed for quality against a set of predefined criteria of good design. So whenever we are working on software design, we have to ensure that the model that we are developing is coming from or is based on the requirements of the customers. And as we continue to develop software design, we continue to assess its quality, because if we don't assess for quality right from the beginning, we will have difficulty in assessing for quality at the end of the development life cycle. And if we want to have a high quality software product, we must start upstream. We must first have a high quality requirement set and then start performing design activities with focus on software quality. Software design is different from other forms of design because it is unbounded. It is not constrained with the physical objects like a chair or a table, and the regular laws of physics do not apply to software design. As a result, software design becomes a very complex activity because any number of factors are affecting the development of software design. The possibilities are conceptually unbounded, and so and it is first, and there is another problem, and that we cannot see the design with our own eyes, although we can assess the quality of it by performing certain quality assurance activities on the design that we are working on, but we cannot see design with the naked eye, or it is something that cannot be seen, and that's just the nature of software. Many times the tasks are ill-defined and suffer from incompleteness and inaccuracy. And this incompleteness and inaccuracy are typically coming from the requirement set. If care has not been taken or given at the requirements development activity, the requirement set would contain many flaws which will then result in a design which contains those flaws. Sometimes those flaws are obvious and result in contradictory design characteristics, and then they can be corrected at that time. But many times these errors are detected very late in the development life cycle. Similarly, there are few predefined solutions available, but there are a lot of solutions, there may be a lot of solutions available which can be applicable in one scenario or another scenario. So the choice becomes difficult to make a choice between the existing solutions that are already available in different repositories. There is another problem with using existing solutions, is that one has to have knowledge of the existing solutions, and that is something which is not very intuitive. It is not, the existing solutions are often not well known in the software engineering community, although some commercial solutions are available. Secondly, if a similar solution exists in a different application domain, then one has to have some knowledge of other domains also. So there is interdisciplinary knowledge that has to be part of complex software design activity. And software solutions, if they exist in repositories and are available, can have multiple interface mismatches, because the existing solutions were not developed keeping in mind the needs that a designer has at any given time. So anything that exists before the new design activity may not be 100% compatible with the current need, and so there have to be some wrappers developed around those components to make them useful for the current design activity. So design, as I said, is a very complex but very challenging and very interesting area of work in software engineering. And to come up with high quality design, one has to develop lots of design, has to understand a lot of design, and develop an approach to creating quality software designs. Experts usually follow the breadth first approach. That way it allows them to mentally simulate the execution of an evolving system to detect unwanted interaction between components in the new software system. It allows them to detect inconsistencies, weaknesses, and incompleteness of their software designs. And we cannot expect to become an expert in software designs overnight. As I said, that you have to keep trying, designing new softwares, looking at how experts have designed their softwares, and be comfortable with different design concepts and design principles that we will be discussing in these lectures. And so there is another thing that designers continuously face, is that the goals are, especially the performance goals, are shifting dynamically with respect as they continue with their design activity. And so they have to ensure that they meet those requirements. Because remember, we talked about the change in requirements on a regular basis, even if they have officially ended. That is, the development life cycle has ended. And good designers structure problem formulations by discovering missing information. That is very important, because I've said earlier also that in many situations you would find that the requirement sets was incomplete, and that incompleteness was not detected at the requirements level, but when you are performing design, you end up needing few things that are missing in the requirements. And there are so many open-ended issues that must be resolved before design can be completed. And so at that time, the designer has to find these things and close these different kinds of issues so that a high quality software design can be created, which will then ultimately result into a high quality software product. And so this requires that a designer, as I have said before, that each expert designer has developed an approach to working on software design. Some of them use existing design methods, which are also very useful, and the selection of a design method depends on many things, which we are not going to discuss here. Even if you follow a particular approach, you can follow any method. For example, you can follow Code and Jordan, or you can follow UML-based software development methods, or you can use Booch's method, or any other method, for example. Occasionally, designers must try new things, new innovations, to keep the creativity alive, even if the designer is following a particular approach. It does not mean that they cannot try new things or applying combinations of existing language structures in those methods. So that allows the designer to come up with a creative and genius solutions. Software design principles identify strategic approaches to production of quality software design, while software design practices identify tactical methods for producing quality software design, and software design procedures provide an organizational framework for designing high quality softwares. And all of these three are necessary, and they work together to provide to achieve the ultimate goal, which is, in the first iteration, a high quality software design, and ultimately a high quality software product. These two are tightly coupled together. You cannot expect to have high quality software product without a high quality software design. These are two intertwined things. This was a basic introduction on software designs. One thing that I would like you to remember is that everything, every concept, every principle, every practice that we talk about with respect to software design, associate that with software quality. Associate that how this practice, think how this practice can increase software quality, if we don't perform that practice, can negatively impact software quality. The ultimate goal is we want a high quality software product. And for everything we do in software engineering activities, we need to keep this thing in our mind. Every step of the way, every milestone that we pass, every milestone that we set, every goal that we set and then achieve, we must keep in mind that how far have we improved our quality. And if we do that, and when we do that, and we do that continuously, we will be able to perform better in every software project. And that's where the measurement, the concept of measurement comes into play. And we have talked about a little bit on software quality measurements in a lecture earlier. Now, design, as I have said before, is the place where quality is fostered in software engineering. Yes, we do require high quality requirement set. And yes, we endanger the software quality for the product if we don't worry about requirements and we don't develop a high quality requirement set. But design is where we start making the solution. And so design provides us a representation of software which can be assessed for quality right from the beginning. Design is the only way we can accurately translate a user's requirements into a finished software product. What we risk if we don't have software design is a product which will fail when small changes are made to it, a product which is difficult to test, a product which cannot be assessed from quality from the beginning, we have to wait till the end, a product which may not be reusable, or a product which does not contain reusable components, and a product which may not meet the needs of the customers even for that particular project. So design is very important, and high quality design is even more important. We have used the term design in a very broad context. We said in the beginning of the lecture that we have two things. We have design model as well as a design process. Up to this point, we have broadly used software design as both a process and as a model. So we can say that software design is a model as well as a process. As a process, it is a sequence of steps that enable the designer to describe all aspects of the software to be built. So in other words, if we consider design a process, it is going to result in a design which is a model. During the design process, the quality of the evolving design model is assessed with a series of different quality assurance mechanisms. It needs creative skills, it needs past experience, a sense of what makes a good design, and an overall commitment to quality. These are the skills that you need to perform the design process so that you can end up in a design model. The design model, on the other hand, is equivalent to an architect's plan for a house or a building or a school or anything, or any construction site. It represents the totality of the thing to be built. So the model would have everything in it that the software solution will have, but it would be a representation. It will not be the real thing. And the model provides a variety of different views of the computer software that will be built from it. And so in that way, you can view the model with different perspectives. And you can analyze that model from different perspectives. And so the design process ends in a high quality software design if we follow the process faithfully and we apply the design principles and design concepts, which we will learn in a different lecture. So this was our discussion on software design process and software design model. Now let's talk about a very important concept related to quality assurance in software design, and that is design defects. We know that defects introduced early in the life cycle are typically found later in the project life cycle. Now, if the defects were introduced in the preliminary design activity, they are found in integration testing, and that is the situation which normally happens, which is very late in the development life cycle. And defects introduced into the detailed design activities are usually found in the unit testing. All four categories of defects are found in design models. We have errors of commission, we have errors of omission, we have errors of clarity and ambiguity, and we have errors of speed and capacity. And all four of them can be found in design model. That is, all four of them can originate in design process. Most common design defects are errors of omission. The second most common are errors of commission. Errors of clarity and ambiguity are also common, so they fall at the third level. And many performance related errors also originate in the design process. So we see that all four of them are available or can originate in the design process, and they end up in design model. If we look at the complexity and difficulty levels of design defects, we find that they rank next to requirements as a source of very troublesome and expensive errors, because the errors you make at the design process or design activity are typically because of misunderstood or wrong requirements, and you have not fully understood the application domain, and you're making those errors which will be discovered when integration is being done, and that is very late in the software life cycle. So they are very expensive and they are very troublesome because they are difficult to find. What can we do to eliminate design defects? That's the same approach that we would take with any other work product or any other activity is that we have to apply both defect prevention techniques as well as defect removal techniques. The best defect prevention techniques are obviously education and training, which make the designers more familiar with the application domain, with the tools and methodologies and techniques that they are applying, the practices that they are using, and the internal procedures that the organization has formulated to come up with high quality software designs. Another thing is that sometimes designers don't pay attention to fundamental research in computer science and software engineering, and they overlook those fundamental high quality design concepts and design software systems which ignore those things, or are at least are not used in a very professional manner. We will talk about what those high quality design concepts are in a different lecture. As far as design removal, as far as defect removal is concerned in software designs, design inspections are the best way to detect and then remove design defects. They are the most powerful and successful software quality approach for design defects. So my suggestion to software engineering students and software engineering professionals is to incorporate design inspections in their software development process, especially in their design process. Now we will talk about defects in fundamental design topics. Here you are seeing 7 fundamental design topics, which I will read and then we will discuss each one of them. The first is functions performed. Second is functional installation, invocation, control, and termination. Number 3 is data elements. Number 4 is data relationships. Number 5 is structure of the application. Number 6 is sequences or concurrency of execution. And number 7 is interfaces. These are fundamental design topics where defects occur. Functions performed was the first design topic where we can say that design defects occur. These are errors in descriptions of functions that are functionality of the software system that the application is supposed to perform. If a careful analysis of different projects and different software applications is done, we find that often problems in functionality as far as design errors are concerned are errors of omission. So things are left out. Things are left out because the domain may not be fully understood, and as a result, this would end up in dissatisfaction of the customer. Often these omitted functions are those which are implied functions rather than explicitly demanded functions. So how we deal with this? We deal with this by providing education and training to designers on fundamentals of that application domain. This is very important. I've said that before with respect to requirements, and I say that here with respect to design, that both requirements engineers and software designers must be comfortable with the application domain. That is, they must have a comfortable level of information and knowledge in the application domain that they are working on. The next design topic is the function installation, invocation, control, and termination. This is a broad sub area, but if you analyze the complaints from customers of the commercial software vendors, 50% of the problems reported to commercial software vendors are of this class. Defects in information on how to start up a feature, control its behavior, and safely turn off a feature when finished are common in commercial as well as in in-house software applications. This may not be particularly the control and invocation and termination aspects are not applicable in many information system softwares, but in real-time softwares, but in systems where certain functions must be kept under secure management, this can be a problem. So a lot of design care has to be given when designing these sorts of functions. Third is the data elements. Errors in describing data used by the application are a major source of problems downstream during coding and testing. A minor example of errors due to inadequate design of data elements can be seen in many programs that record addresses and telephone numbers. This seems like very simple, but the fact is that if a customer's name is not completely recorded with a service provider, that can cause real irritation with respect to the user satisfaction. For example, if the field for storing a name is only 15 characters and the name of the person fits in let's say 25 characters, then 10 characters of that person's name have to be either stored as initials or dropped altogether. And this is a problem which is prevalent in our community. I have seen so many problems, and I get myself frustrated so much by those applications which are not even written in such a way that they can store the name of the customer completely and properly. So don't think that this is a problem which is a superficial problem. No, it is a real problem, and software designers have to give care to designing data elements so that they can be comfortable, they can store the names and other information, other data elements properly. This is directly related to user satisfaction, which is the ultimate goal of software quality, which is the ultimate definition of software quality. And the next important design topic is data relationships. Errors in describing data relationships are very common and a source of troublesome errors, and a lot of effort needs to rectify or correct these errors in the later stage of software development. If designers don't pay special and careful attention to developing relationships between different data sets, then these relationships can result in problems which can sometimes result in repopulation of database, and that is a troublesome thing to do. A lot of activity has to be done to rectify minor problems. If care was given by the designers, these things can be avoided fairly easily. Then another thing that is more technical, or it at least appears more technical than the topics we have discussed so far, and that is the structure of the application. Complex software structures with convoluted control flow tend to have higher error rates. You must have heard the term spaghetti code. If you design your product in such a way that it leads to spaghetti code, then to find errors, to check for check if the functionality is working or not, even just to read the code becomes very difficult. Poor structural design is fairly common and is often due to haste or poor training and preparation for designing and development. There are tools which can measure the cyclomatic and essential complexity of the code that results because of these design errors. However, prevention is better than attempting to simplify an already complex software structure. And so if you can avoid developing such a messy structure, that is better than trying to clean up and refactor that messy structure. The next design topic is sequences or concurrency of execution. Here we have the notion that certain things are happening one after the other, or certain things are happening at the same time, that is concurrently. Many errors of speed and capacity have their origin in failing to design for optimum performance. If we have situations where concurrency can be utilized and it blends to the application domain, we should do that. Parallel computing is also a related area. If there are multiple processors available, then that can be further utilized. Even if they are not, the software can be designed in such a way that concurrency can be exploited if it exists in the application domain. Performance errors are a result of complex control flow. Sometimes they are there because of excessive branching, that we have utilized concurrency too much, and so we have different branches of the program trying to run at the same time and trying to get the processor's slot and trying to upgrade their own priorities. And they can be because of the fact that there are too much sequential processing. So in that case, we can apply the concept of parallel processing, but again, you have to understand the application domain here, because all application domains do not allow parallelism. They do not allow concurrency. So, but many do. And for many of the real-time applications, this is an area which requires lot of attention of designers. Another thing is that you have to try to minimize I/O operations, because I/O operations can also result in some of the performance errors. Then we have interfaces. Interfaces are sometimes the chronic design problems. Interface mismatch is probably one of the most common types of errors that we face in large complex systems. I know many examples in which there was one sort of mismatch or another sort of mismatch whenever information is being shared either through direct interfacing or direct messaging, or even through databases or third-party message communication. Incompatible data types in message communication is a serious problem, and usually this doesn't get detected practically until such time where we are performing the integration testing. And if that is the case, that they are discovered there, then that's very late in the software life cycle. It will force us to go back and redo many of the things. It will force us to go back and redo parts of design, and certainly redo parts of coding activity followed by unit testing. And so if we can avoid these kinds of problems, then our design would be of much higher quality. These were the 7 fundamental design topics where defects occur. Let's just briefly mention errors in 8 secondary design topics. We will not discuss them. You have the reading material to go through them at your pace. Security, we have reliability, errors in maintainability, performance. There are human factors in software design. There are hardware dependencies that would force us to design one way or the other. There are software dependencies, and then there are packaging issues that relate to software design. How we would like to address these, first and foremost, is that we have to continuously evaluate our design model and design process, use design inspections. Some authors like to call them formal technical reviews, which have proven to be the most valuable mechanism to improve quality of software ever, and especially software design. And then you have to learn the design principles, guidelines, and fundamental high quality design concepts and apply them in your software, in the development of software application, development of software design. You also have to think about software design, develop a sense of what is high quality design, read and analyze other people's software designs which are available in public domain, and learn different techniques that are published in the literature. Today we have talked about what software design is, what software design process and what software design models are, what is the difference between the two, and we have looked at software design defects, what kinds of defects occur in design work products, and how we can address them. In the next lecture, we will continue this discussion, and we will talk about design principles and design guidelines because they will result in the development of high quality software designs. So Allah Hafiz.